Now we're going to talk about AVL trees and red-black trees in C++. Now before we start coding, let's understand the concepts behind AVL trees and red-black trees. Both structures are binary search trees that maintain balance by performing rotations when necessary. AVL trees use height balance, ensuring that the difference in heights between left and right subtrees is at most 1. Red-black trees use color properties and perform rotations to maintain balance. These self-balancing properties enable efficient search, insertion, and deletion operations. Let's begin by implementing AVL trees in C++. And this entire code will be in the description if you want to follow along in Replit or your IDE of choice. In this code snippet, we define a class called AVL tree to encapsulate the functionality of our AVL tree. It consists of a struct called node, which represents a node in the AVL tree. Each node has a key value, height, and pointers to the left and right child nodes. The height function calculates the height of a node by returning 0 if the node is null, or the height stored in the node otherwise. The balance factor function calculates the balance factor of a node by subtracting the height of its right child from the height of its left child. The rotate left and rotate right functions perform left and right rotations, respectively, to balance the tree. The insert function recursively inserts a new key into the AVL tree while maintaining balance using rotations when necessary. The in-order traversal function performs an in-order traversal of the tree and prints the keys. In the main function, we create an AVL tree called AVL, and we insert several keys into the tree, and then print out the in-order traversal. Alright, now let's move on to implementing red-black trees in C++. In this code segment, we define a class called red-black tree to encapsulate the functionality of our red-black tree. It consists of a struct called node, which represents a node in the red-black tree. Each node has a key value, color, either red or black, and pointers to the left, right, and parent nodes. Within the red-black tree class, we have several helper functions. The insert function recursively inserts a new key into the red-black tree while maintaining the properties of a red-black tree. It uses the fix violation function to handle classes where the red-black tree properties are violated. The fix violation function applies the necessary rotations and color changes to fix violations of the red-black tree properties. The rotate left and rotate right functions perform left and right rotations, and they maintain the red-black tree properties. The in-order traversal function performs an in-order traversal of the tree and prints the keys. In the main function, we create a red-black tree object called rbTree. We insert several keys into the tree and then print the in-order traversal.